Hi and welcome to my maths class. Today we are doing a revision for all the grade 10 analytical geometry. Now, let us look at the following drawing. What I would like to know is how to calculate the distance of line AD. Now, distance is equal to the root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, analytical works on three basic rules. Basically, you're going to mark your x1, y1 and your x2, y2. Then you're going to substitute into the correct formula and you're going to solve. Now, if I want the distance of AD, then I'm going to mark my x1, y1, my x2, y2. Now remember, it doesn't matter which one is x1 and which one is x2. What does matter is that you will not mix your 1s and 2s. So when you have x1, then you must have y1. You can't have x1 and y2. Now, once we marked our x1, y1, x2, y2, we're going to substitute into the formula. So we have 3 minus 2 plus, and then we've got minus 1 minus 6. You can then use your calculator and you'd have the distance is equal to 50, the root of 50. 3 minus 1 is 1 squared, which is 1. Minus 1 minus 6 is minus 7. Squared gives us positive 49, which is equal to root of 50. Right. So the first thing you learn usually in grade 10 is your distance. The next thing is calculate the midpoint of AC. Now the formula for midpoint is x1 plus x2 over 2 is equal to the x of the midpoint, and y1 plus y2 over 2 is equal to the y of the midpoint. So, since we've already have an x1, y1 there, what we do is we mark this as x2, y2. Then we're going to substitute. So I'm going to have 2 plus 8 divided by 2, which is equal to 5. And I'm going to have 6 plus 4 divided by 2, which is equal to 5. So our midpoint is 5, 5. Right. You would notice that from one drawing we can do many concepts of analytical. Let's continue. Right. Using the same drawing, the next question would be get the M of AC. Now, the coordinates of A is 2 and 6 and C is 8 and 4. We've already marked it. So what formula are we going to use? Since we're working with gradient, we know it's going to be y2 minus y1 over x2 minus x1, which will give us 4 minus 6, 4 minus 6 over. Then we have 8 minus 2. So our gradient is equal to minus 2 over 6, which is equal to minus 1 over 3. Right. And then they say calculate the gradient of BD. Now, if you look at B, we have calculated B from here where they said calculate the midpoint of AC. Now, AC was this line. So, the midpoint is at B, which is now 5 and 5. Now, how do we calculate the gradient of BD? We know we've already marked D as x2, y2. So what we're going to do is mark this as x1, y1. Now we're going to substitute. So it will be 5 minus minus 1, we know it's y2 minus y1 over x2 minus x1. So we have 5 minus minus 1 over 5 minus 3. So our m is equal to 6 over 2, which is equal to 3. Then they would ask you, what can you decide regarding line BD and line AC? So line AC and line BD. If you look at their gradients, the gradient of AC is equal to minus a third, and the gradient of BD is equal to 3. Now look, minus a third times 3 is equal to minus 1. What we know is that m1 times m2 is equal to minus 1, therefore they are perpendicular. Right. So what have we learned from our summaries? Number 1, you need to know the distance formula. Number 2, you need to know the midpoint. Right? Our distance formula, your distance is equal to the root of x2 minus x1 all squared plus y2 minus y1 all squared. Then your midpoint formula is x1 plus x2 over 2 is equal to the x of midpoint, y1 plus y2 over 2 is equal to the y of midpoint. At all times we're basically using the same 3 rules. You're going to mark your x1, y1, x2, y2. Then we are going to substitute into the correct formula, and at the end we're going to solve. The next thing we learned was the gradient. Again, the formula for the gradient is m is equal to y2 minus y1 over x2 minus x1. What we also know is that m1 times m2 is equal to negative 1 would mean that the two lines are perpendicular. They are 90 degrees to each other. Now, besides this, what else we have in our summary is parallel lines. Right. What we know from parallel lines is that m1 is equal to m2. So if I'm working, again we're going to mark our x1, y1, x2, y2, and we're going to do the same to the other line. Now let us substitute. If we have this as line AB and we have line CD, so we're going to work out the line of AB, and since they parallel, we know it's going to equal to CD. We have 0 minus y over 1 minus 3 is going to equal to 1 minus 3 over 1 minus 0. Now if we solve the side, we have 1 minus 3 is minus 2 over 1, which is equal to minus 2. Here we have minus y, 0 minus y is minus y over 1 minus 3 is minus 2. So we got y over 2 is equal to minus 2. To get rid of the y, we're going to multiply by 2. So I have y is equal to minus 4. Now look at the rules. Number 1, we knew that they are parallel. We marked our x1s and our x2s. We substituted. And then we solved. So the rules are exactly the same. It is always the same 3 rules. Mark, substitute, solve. Right. The other concept that you had learned in grade 10 is that when they are collinear, then m1 is also equal to m2. So they could ask you in a parallel form, or they could say collinear. But when we use the words collinear or parallel, we're going to use the concept m1 is equal to m2. Thank you for watching.